Uh, yeah, my team and I goal has been to refactor the whole backend and frontend of Deister technology platform. And for those who don't know what Deister does, I'll give a just quick sentence about what we do. But basically, Deister has a technology platform that incorporates data fabric, data analytics, application building using low-code capabilities. And with all of that, we build enterprise applications, especially ERP style applications. But today we're going to focus on one of the features that we have, which is how we are incorporating AI, especially an special agent that we have built, which is the text to SQL agent that uses Informix database and Watsonx from IBM. So yeah, I'm gonna share my screen and I'm gonna go through a quick presentation and some live demonstration of the platform. And again, if someone has some question, please feel free to ask, okay, at any time. Okay. You all see the screen, right?
Yes.
Yes, we do. Sorry, I was muted.
Perfect. Perfect. Okay. Thanks for confirming. Okay. So what is the foundation of what we're going to see today? Basically, it's built upon these three key points that we see on this slide. The first one is that in our platform, we can define table schemas using an abstract language definition that I will show you in a bit, that is written using XML. The second thing is that these schemas can include descriptive metadata, which is extremely beneficial for large language models like Watsonx. And the third point, which is extremely important for us, is the security, which in this foundation that we have built, we ensure that users that use this agent are only authorized to see the data that they have access to. This is the security that has already been applied in the application, but we guarantee that using this agent, we inject the same security. Okay. So how do we? What's the goal? No, what do we want to obtain using this agent? We want that end users can ask business questions using plain language without the need of knowing SQL knowledge. We find that many times end users require for specific reports or making some adjustments on existing ones. So we want to give these end users the capability or possibility to just ask using plain language and obtain trusted results. No. So here we're going to see the key piece, which is the text to SQL agent that will interpret the user query and generate SQL aligned with the enterprise schema and business logic. And with that, we verify that we obtain a trusted result that respects security, permissions, and also very important, presentation rules. Okay, you will see afterwards when I demonstrate it, but essentially what I mean by presentation rules is that if you have a table that has been decorated, meaning that if you have a column that whose values are 0, 1, and 2, and you have decorated this column so that a specific icon appears for each value, we do respect this decoration when you use the agent, which is very important also. So what's the challenge? The challenge is that business users cannot write SQL and create dependency on developers. even for simple queries sometimes. The second thing is that we deal with complex schemas, complex databases. We deploy and we run large ERPs, CRMs, warehouse management, HR applications that have complex schemas and they are interconnected. So it makes it hard to find the right data for AI. And the third thing is that generic chatbots that you can plug into your applications will obviously ignore the business logic and security. So this is also a very important key point for us. So let's go ahead and see what is the infrastructure in a high-level overview. But basically, what we're gonna see is the main agent architecture, which essentially has a system prompt with instructions on what is the current context, and it has access to different tools. Some of them, for example, to get previous conversation history, so access memory. It has access to a RAG tool to search for documentation on the current application context. It has also access, obviously, to the user profile information like language, time zone, preferences, etc. And it can plan and utilize other tools that can be defined per application. Okay, so for example, HR or ERP application can define its own tools that will be incorporated into this agent architecture. So when a user makes a query, the main agent takes action, and based on the user query, it decides if it can delegate this user query to an specialized agent, which are the ones that we see here below. In this presentation, we're gonna focus on the SQL agent. So basically, when the user makes a query, the agent detects that it exists an specialized agent that can respond to the user in a much better way, which in this case would be the text to SQL agent, and it invokes it. Okay, so let's take a look at what does this SQL agent have. Well, this is the main agent overview that we just covered. This is the delegation of the user query from the main agent to the text to SQL agent. And the text to SQL agent has, again, a system prompt with some instructions and has access to 3 tools. The first one is a tool that allows the LLM to list the application tables. And this list contains also user-friendly descriptions that we have previously defined on the XML model definition that I explained before. So once it has the list of tables, it can then decide what specific schema to fetch from the list of tables. And this tool retrieves the table columns, including its types, the check constraints, foreign key relationships, everything. No? So it obtains the information of the tables that it needs to formulate the query. No? So once it has the table schemas of these tables, it can go ahead and use the design query tool, which it's important to mention here. This tool only defines a structured XML query. It does not execute it. So it ensures that the query is aligned with the schema and respects everything that we have previously fetched. And once we have this query, it is ready for execution by the main agent again. Okay, so until this point, the text to SQL agent has designed the query, not executed it yet. Okay. So once we have this query design, it is then passed again to the main agent. And the main agent then says, okay, based on the user query, I can maybe respond in plain text. So it executes the query and responds in plain text. Or maybe based on the user query, I can replay in tabular format or in chart or in a document format. For example, when the user says export data to Excel or PDF. So an important aspect here is that, as you can see, data is not being sent at any moment to the LLM. We are the ones that run the query, and we only provide the tools so that the LLM can formulate a business-aligned query that will be later on executed by the system. An alternative to this approach, maybe some of you are thinking about it, is to fine-tune an LLM. But fine-tuning, first of all, you are locking in with an LLM vendor, the one that you pick, because fine-tuning is different for every LLM. It requires a lot of work because you need to prepare data sets with clear inputs and outputs to train the model on how to do these kind of tasks. And the third point, which is very important, is that you don't have real-time data then, because obviously you need a pipeline that fine-tunes the LLM model every day or every week to have fresh data from the application that is coming in the application. With our approach, we ensure that the queries execute in real-time data. We don't train LLMs, and it's an approach where, again, data is not sent, only metadata is sent to the LLM. Regarding the security injection, it's important to mention that in our system, whenever you run a query that involves tables, the system knows how to inject security for these tables, for the user that is executing the query, obviously. And it also knows how to decorate the result based on the presentation design that you have defined for the tables. No? So quick overview, but basically we're taking a look at our solution versus a generic one. Some of the points that we mentioned before, no, but first of all, schema awareness for a generic text-to-SQL chatbot is disconnected, obviously. In our case, it's aligned. Business logic, again, is ignored. In our case, is fully enforced and matches the application rules that you already have defined. Security and permissions, again, not enforced, or you have to inject the security from the external system. In our case, it's automatic. Output presentation, again, this one, the generic one, does not know how we want to present, for example, the table row. And in our case, we have complete decoration and alignment with the UI decoration that the applications already have. No? So taking a look at the complete workflow, this could be a real scenario. No, the user says, "Show me the top 10 customers by revenue growth this year, excluding Europe." The LLM takes action here and transforms the user natural language into a structured task that is passed to the SQL agent. We do this step here because I think most of you will agree with this, but users do not know how to ask questions. So we have this intermediate step here where we transform the user query into a more professional instruction that is passed then to the SQL agent. Then the SQL agent takes action, and what it does is it lists the tables. It retrieves the schema for the tables that it needs to formulate the query, and then it generates this XML query design. Once we have the design, we pass it to the main agent, and in this case, we execute the query, applying the security and business logic, and the user can even follow up, for example, saying, show it this result as a pie chart. And it will know all the previous context, so it does not have to go through all this again, and it can automatically then generate the chart. No? So let's go ahead and look at the system. So let's go ahead and check the definition of an application. So we're going to take a look at a CRM. This is where we define the actual application. So as you will see, everything is defined on a database, which is also running on Informix, that we call dictionary. We're going to go to the dictionary tables of this CRM application. And here you see that we have 58 tables in this case. So we can take a look at, for example, CRM contact. And here we have the table definition. Again, this is optional. You can, in this system, define table schemas using this XML syntax, or you can do it natively. But using this syntax allows us then to transform this query into any database engine. And it serves also as a catalog and metadata that, as I was explaining, is very important for LLMs. No? As you can see, we have information on all the fields, and all this is passed then to the LLM. An important thing about the system is that when you define the tables, you're modeling the application. These tables need then to be deployed on the actual application. So we have this tool that allows developers to pick an actual database. As you can see, we have a demo CRM, and then we have some production CRMs here and a test CRM. So why do these applications appear here? They appear because they have this dictionary that we're seeing now attached. So we can say, okay, let's take a look at the test CRM application, and I want to get a status of everything. So what this process is going to do is it's going to check the actual model definition that we have here against the actual database, which in this case is Test Cloud CRM. So as you can see, we already have some issues on this Test Cloud CRM. We have some missing unique constraints, but I want to show you a real use case, which is going back to the CRM contact. Let's say we want to change the size of this column. Okay, so we can come here to the size, and we can increment this to 70. The system always asks for a commit message. So I would say, please, size of company surname. And when I do this, the system automatically generates a delta change, as you can see. And I can always click here and see what has been changed on the model. So going back, for example, we can see some other delta changes made on the model. Okay. So doing this has not affected the actual database yet. To do that, what I would need to do is go back to the compile tool, pick up the database that I want to deploy these changes, and if I execute this process again, you will see that now we have this new error. No, it's telling us for the test cloud CRM, the column contact surname expects a length of 70, but we found 64. If the user has permission, which in my case I do have, I could click here on this link and I would execute the repair statement automatically. So this is just a quick overview of how the system works. As you can see, we model the table definitions. We can enrich these tables with also descriptions for each label, tooltips, hints. Also, even the table has a field where we can explain what it does. No, and based on this model, we can now go to an actual application, which is the CRM application that I was mentioning before. And I can always come here and open up the chat. No? So what I'm going to do is I'm going to say, show companies by priority. And what we're going to see now is that the agent, first, it searches for application objects that may contain some relevant information to answer the user query. Then, as you can see, it has delegated this task to the specialized text-to-SQL agent. And inside this process, what we will see now is that it has listed the tables, retrieved the table schema for these tables. And once it has the table schema, it generates, well, it designs the query, and we can then execute and obtain the results. So as you can see, as we were mentioning in the keynote presentation, the result respects both security and presentation layer. So as you can see, for example, the company priority, which in this case, we can check the data model, but it's a small int with some values, it's respecting the actual column decoration. No? In this case, it's a flag. Or, for example, the annual revenue or employee range. It's taking the column decoration, okay? So we get this result, and if we click here, since my user is a developer, we can take a look at what it has done, no? So as you can see, the first thing that we see here is that it's called the delegate agent tool. And the task that it has passed is the following: create a query to show companies organized by priority. Include company name and other relevant details, ordered by priority level. Okay? So this is the transformation that I was mentioning before. This is the end result, but before we see the end result, you can see that this SQL agent has first listed the tables on the system, and then it has fetched the table schema for CRM company. So as you can see, we pass the table information and all the column information, including the column type, description, etc. No? Once we have this, the agent decides to design the query, which in this case, as you can see, we have generated the query using this XML syntax also. And finally, the agent has decided to create a data table. So here we have the results and the transform query in Informix. You can see it here. Plus the security injection from the tables. Okay. So now I could say show as a pie chart. So I'm going to do a follow-up question on the previous one. And what we would hopefully see is that it understands the previous context, and it should be able to generate, in this case, a pie chart for the previous information that we fetched. So let's see. Yeah, now it's creating the chart. So as you can see, if we take a look at what it did, here is we have a summary of the previous things that we have done. The query design is this one. So we can see that it used the previous query context to formulate a new one. And then it called the create data chart, and it picked correctly the pie, the dimensions, titles, and measures. Okay. So checking a little bit more complex queries, I'm going to jump to the ERP application. And if I open up this previous conversation, I did one before that was quite interesting, which was this one. So we can even do it bigger. So in this ERP application, I asked, okay, provide me with a detailed bank statement report. So as you can see, it has been able to generate this bank statement report. And then I say, okay, create a cool insight based on the previous information. And it generated this total calculations. So we can take a look at the query, which is quite more complex than the one that we saw before. So as you can see, the workflow is the same. It detects that it needs information for this specific table. It fetches more information for other tables that it saw that were important. We're seeing here some check constraints, which is also key point for LLM to understand the check constraints. And based on this information, it generates this XML query, joining with several tables and doing some complex filters here with dates. And with that query, we can execute it. And here we will see the actual Informix query. Okay, we have it here. So this is a little bit what I wanted to show today. I don't know if you want to see or you have any question about a specific topic. But yeah, this is a little bit what I wanted to show today and share with you.
Vicente, do you want to directly ask the questions you put in chat?
I have here the chat.
Okay.
I hope you do it. Anyway, okay, two questions. So first one is, so as you're explaining, you need some kind of schema metadata aligned to the real table schema to allow the agent to pick the proper tables.
Correct. Yes.
Okay. Yes. Okay. So without this metadata,
exactly without this
will work.
Without this metadata, like in this case, the CRM is very descriptive. No, the actual table names and the column names are very easy to understand. Okay. But we have some customer applications where fields are not understand. An LLM does not understand what it means. No, so that's why adding these descriptions on columns and on tables is extremely important for this agent to work.
Okay, and next question is, why are you constructing the queries using some kind of XML abstraction language instead of using native SQL language?
For basically 3 reasons, and I will go through all of them. The first one is that LLMs may be good at some database and maybe better at some database engines than others. And we detected that when we were starting to work with this. Second point is that we inject security automatically when a query is written using XML. And the third point, which is very important, is because this abstraction of the query is extremely beneficial for LLMs, and I want to show you why. So let's go and check SQL functions, and let's go and check I want to see the date functions, date build, MDY, okay? So this is how we build an MDY query using this XML syntax. Below, you can see how it is written in these database engines. Informix is the best one, as you can see here. It's clearly identifiable, okay? But nevertheless, we have complexity building complex queries, no? So this abstraction is extremely good for LLMs to understand, and doing some benchmarking that we pass every day, no? We found out that doing and instructing the LLMs to use this XML syntax was, well, we obtained a much higher accuracy and lower rate errors. But it's for these three reasons mainly.
Okay, thank you.
Thank you. Anything else? I think
All right. So, as always, feel free to, if you have follow-up questions, let us know. Thank you so much. I mean, this is, for me personally, very interesting because there's so much talk about AI and LLMs and not a lot of real world, showing how they can be used and specifically how they can be used safely against databases. So, I mean, for me personally, this is fascinating stuff, and really appreciate you coming in to present for us today.
Thank you, Tom. By the way, if anyone is interested in trying this out, you can absolutely reach me, and we have a dedicated environment where you can test it out with Informix databases. Okay.
All right. And what is apologize if it was in the slides, I missed it. Is your email in there, or what is the best way for people to reach you?
Yeah, my email is fine to reach. If you want, I will type it here.
Yep. So it'll be in the video in case folks want to reach out later on.
Okay. Excellent.
So, all right. Thank you so much. If anyone has follow-up questions, reach out. And I'm going to go ahead and stop recording on this one.
Perfect. Thank you, Tom.